on this morning. There may be a few people joining as we go through the session, but I don't want to keep the rest of you held up here. A couple of you have been on the line for about 15 minutes now waiting. So again, welcome, and we'll get started with our session today. So on our last session, in session 2, we talked about some failures of lubrication and lubrication systems. And today we're going to present some different things we should be doing to eliminate those failure modes as you go through lubrication. If there's any of you on the webinar for the first time, again, my name is Terry Harris. The name of our company is Reliable Process Solutions, and we kind of specialize in helping people move their facilities and operations to higher levels of reliability. So you can see from this slide here, we do a lot of things. We actually do RCM facilitation. We actually have our own RCM software, a couple of different versions. We do a lot of lubrication excellence training in these areas of lubrication and lubrication equipment. And we also do a lot of other courses. We do some courses directly for maintenance people that talk about how equipment components fail, such as motors, bearings, and just about any equipment component you'll have in your plant, which gives them a better understanding and also helps you and the maintenance people to write some more effective PMs, or actually to perform some more effective PMs, because the only way to develop a PM is to know what the failure modes of that specific equipment may be, and then you develop PMs around how that equipment can fail. And all the way down to the bottom, we do the lubrication storage equipment and trailers and things like that. We'll look at a few of those as we go through the slides as far as some of your remedies for getting particles out. So again, always training off the PF curve, where we have our reactive failures to the right side of the curve and where people mostly do maintenance, all the way up to where we are on the left-hand side of the PF curve. And we're still in this one called Lubrication Excellence. Next month, we're going to do some predictive technologies and just keep moving down this performance failure curve here, trying to get to the point where you can make your processes more reliable by how do you combine these processes, which ones do you do, and that'll be covered in our last session of the year in the recap. So hopefully all of you will learn enough by then that you can get some things going before we even get to that last webinar, but we definitely want to help you get there. All right, so in session number 1 on lubrication, we learned about some of the failure modes of lubrication. We learned how lubricants are affected by temperature and some of the things that happen when they're affected by temperature. Your viscosity goes down. The lubricant actually oxidizes at a lot higher rate. Some of your additives are consumed with the higher temperatures. So temperature is a definite failure mode. We learned a little bit about moisture, how moisture affects the life of our equipment, how moisture in our lubricants are also going to affect those additives and also going to change the viscosity. We learned about some of the effects of foreign material. You know, and as we go along, we need to figure out how to keep that foreign material out. And we also, at some point, we need to also use equipment to get the foreign material out, because a lot of our operations are dirty type operations when you get into foundries, fertilizer plants, drywall plants, or gypsum board plants, a lot of different processes in the industry. Especially the mining industry, we have lots of particle contamination. So first of all, how do we keep it out, and how do we get it out once it gets in there? And then there's all kinds of things with contamination from all other sources. We talked about the moisture contamination, but glycol, different chemicals, different gases that may be around our systems that get into our lubricants and cause failures. And then, of course, how important viscosity is, because as oils oxidize, the viscosity changes. As the moisture level changes, viscosity changes. And as the viscosity changes, we sometimes lose the protection we need on our equipment components. So again, these are the main failure modes that I usually cover in my training. So in this session here, session 2 on lubrication, we're going to look at some ways to control these failures. Now, since we only have an hour, we're going to only have so many, but again, finding the failures, if you see things in your plant, if you have issues, especially if you're on this webinar, make sure you send me an email, and I'll give you some other remedies and other things you can do. And if any of you are interested in doing some lubrication excellence training at your plant, as an example, last week I was in Nebraska for a company, and we did 2 4-hour sessions on Thursday, 2 4-hour sessions on Friday. I actually ran 48 people, supervisors and maintenance people and operations people that actually are affected by the lube task or actually perform the lube task in some way. We ran all those through those 4-hour training sessions. And again, I think they learned a lot. We did the same thing about 4 years ago there. It was a refresher course, and they've actually accomplished a lot of that facility since I've been there. One of the more reliable facilities this company has, so lots of things we can do in that area. But let's look at this first temperature failure mode. You know, increasing as lube temperatures increase, viscosity decreases. We looked at some of those curves. I'll show you one here again today, but this is very important to remember that in mineral-based lubes, temperature has a huge effect on viscosity, and viscosity has a huge effect on your equipment life. So as things get hotter, as things get colder, you have to watch what that viscosity is doing. And most of these temperature failure modes are based around mineral-based lubricants. And it says here mineral-based lubricants oxidize much faster at higher temperatures. So again, we have to be aware of that. If you've got things that are running 150, 160 degrees, you've got to plan on changing that mineral-based lubricant every year. And that's just if you keep, that's even if you keep the moisture out. If you have moisture in there, that lubricant may oxidize before then. But again, as that viscosity decreases, we lose that film thickness, and it's going to result in increased wear of your equipment. So we always have to make sure we have enough viscosity to keep the components from running together. Now, one of the nice things about synthetics, and one of the benefits of synthetics, is synthetics don't go through the temperature changes and that viscosity change as much as mineral-based lubricants. And that's why synthetics perform so much better, and you can use them over a wider range of viscosity areas because the viscosity doesn't change as much. So, but synthetics are much, much better in hot, high-temperature applications in your facility. So here's a chart that comes off of Google, and if you go to Google and type in viscosity charts for your different lubes, you know, we'll see here that we can, this one here only goes from ISO 10 to ISO 100. There's viscosity charts that go all the way up to ISO 1000. But what it's showing here, this dark line right in the middle, that's your 40 degrees centigrade line, which would be 104 degrees Fahrenheit. But if we go up to our ISO viscosity 100 right here in the middle, we can see that ISO 100 is only ISO 100 at this 104 degrees or 40 degrees Fahrenheit. So as the temperature goes up, what this chart is trying to show is as the temp goes up, the viscosity goes down. So you can see even at 100 degrees C, which is 212 degrees Fahrenheit, our viscosity of our ISO 100 is 12. And the same thing happens a lot of times with our equipment. We have to watch that. But look what happens in the reverse of that. If we go down to even 0, which is 32 degrees Fahrenheit, look how thick our ISO 100 gets. It's all the way up to 2,000. So we have to be careful if you've got hydraulic units or gearboxes that are running in outside cold areas. When that gearbox shuts off, that lubricant's going to become very, very thick, and you may not get protection on your components until it heats up. And as the lubricant gets very, very hot down here, you can see that viscosity at some point will go all the way down to round 1, and you virtually have no viscosity at all. So viscosity is an important failure mode we have to understand, and if you have high temperature or really cold extremes, you know, I always recommend you go to a synthetic lubricant. So what do we do with some of these failure modes of our lubricant? Well, we have to find some ways to cool it. If it's in a hot area where it's affected by temperature, are there some ways we can cool? You know, a lot of times it's just keeping the component like the hydraulic unit or the gearbox clean so that dirt's not an insulator. Sometimes we may have to put some air cooling coils on there. Remember at the facility I came from, we just bought some air cooling coils from McMaster-Carr, tied them in, and let the oil circulate through there just by gravity and cool. But definitely if you don't have cooling on there, you have to change that lubricant more often. But I always tell people sample the lubricant for signs of oxidation. You know, some people think in oil analysis you have to always send a sample into a lab. Well, one of the things that I used to do for oxidation, I would buy those round filter paper that you get for a lab, put a couple drops of your lubricant on that filter paper, let the oil start expanding through the filter paper, and then put a date on those and keep them in a Ziploc bag. So as the oil gets dark, you can just compare it month to month. When that oil gets to some point where it's dark, then it tells you you need to change it. And you'll notice when it starts oxidizing, it gets dark a lot faster. So you may go 6 months and it may not change very much, but once it starts changing, the oil darkness will change very rapidly. Improve your understanding of viscosity for all your equipment. I mean, as this temperature goes up, we have to understand what the equipment temperatures are. And a lot of times I tell people an OEM will recommend a specific viscosity for their equipment, whether it's a hydraulic unit or a gearbox, but sometimes the OEM does not know where you're going to install that equipment. So he may not understand they need to change that viscosity. On your greases, greases acts as an insulator with this temperature failure mode. Greases have specific viscosities. So if you don't have the right viscosity in your grease, you're going to build up these temperature modes. Synthetics, again, on any application where you have temperature issues, synthetics are better than any mineral-based lubricant. They're better by not changing viscosity, but they're also better for life. They'll last 3 to 5 times longer at the same temperature range as your mineral-based lubes. So this is one of the things I sometimes argue with corporate procurement departments about. They don't want to spend the 2 or 3 times more for the synthetic, but they don't understand that the lubricant's going to last so much longer, and you're going to have more equipment life. But again, sometimes we have to eliminate these temperature failure modes. Keep your temp reservoirs, gearbox, and equipment clean to dissipate the heat. But look, where's the heat coming from, and how can I reduce that heat? Your moisture failure mode. And again, like we talked about earlier, moisture changes the viscosity of your lubricant. It changes the whole characteristics of the compound of lubricant. So too much moisture is going to change the viscosity, but sometimes the moisture actually changes the lubricant into something that's not a lubricant anymore. And we'll look at a slide of that here in a second. But again, moisture, we talked about that temperature failure. Moisture causes that lubricant to oxidize at a much higher rate. So first of all, we have to know if we have moisture in there. If you've got outside equipment that gets hot and cools down, there's all kinds of ways the moisture can get in there. But we have to find out if there's moisture in there, and then how do we get it out. Again, your additive package, every one of your lubricants, like we talked about in the last session, has an additive package. That additive package can be absorbed by moisture. So some of your additives will mix with the moisture, and you don't have the additive at all anymore. It turns into some other compound, so it's going to affect your additive package in a great way. But if you remember this last session we looked at what the failure modes or what the life extension factor is. And if you just look at the left side of the chart, if you've only got 1,000 parts per million of moisture, and we can reduce that, if we follow that line to the right over to 50, it adds 6 times the life to your equipment. So what this side over here shows is these high moisture levels, you can see what it's doing to your equipment life, because it changes the lubricant to something that's not a very good lubricant anymore. So always, get this chart out. Like I said before, if you shoot me an email, we can send you a little lube manual that we put together that shows you all these little charts like this for failure modes of particles and failure modes of moisture. And you can use this as you walk around your facility with your maintenance people and show them what the effects of this are. We talked about our desiccant breathers. And again, these work very well. You should have some of these on any equipment that's getting moisture in. But you can see the air sentry model on the left, the moisture comes up through the top, goes through a dust filter down through your desiccant. But if these get completely saturated, and I've seen these so saturated at facilities that there'll be mold growing inside of them, but that moisture goes right into the unit. The desk case model here, the moisture comes up through the desiccant on the side. So if these get saturated, at least the moisture drains to the side. And like I say, they're very expensive to change, but they need to be changed. They can be dried with an air dryer. If you need information on that, give me a call, or I won't talk about it on here because some of the breather manufacturers may get mad about that. But and also, I told you in April we're coming out with our breather where you just buy the breather one time, and then you'll be able to change the desiccant. So instead of spending $50 or $60 per breather each time, you'll buy the breather one time, and you may only spend $2 to $5 for the desiccant. So it'll save your company a lot of money by just buying the replaceable desiccant models. And again, we'll have those available in April. If you're interested, give me an email. And then there's different ways with air dryers. We talked about this in the last session. There's different things we can do with an air dryer where you take your hydraulic reservoir airspace, your gearbox reservoir airspace, and we just bleed dry instrument air across that airspace. And not only does it just keep moisture out, but it also causes the moisture in the oil to leave the oil and go into the dry air. Another technique is nitrogen. If you've got nitrogen available, just bleed a little bit of nitrogen into that airspace. If you're at a power plant or if you've got gas turbines or things like that where the oil gets hot and you're getting varnishing, bleeding nitrogen or keeping nitrogen on your oil reservoir will reduce a lot of the varnish you're getting in your system. So a lot of techniques there to keep the moisture out. Now this moisture that you see in your lubricants comes in 3 phases. So the first phase that moisture being in your lubricants is called this dissolve phase. So this is a condition where you have water molecules in the oil, but they compare it to like humidity on a humid day. The water's there, but you can't really see it yet. The second condition is called emulsified water. This is where we have microscopic particles of moisture that are in the oil, but now it's like fog. It actually becomes visible to us. So that's when we have enough moisture in there that it becomes visible to the naked eye. So here's some different levels, at 100 parts per million. And really, to tell you the truth, I've looked at a lot of oils, and I'll show you one here in a minute that's 300 parts per million, but unless you look at your oil real close, I don't ever start seeing it till you get around 500, 300 to 500, and it's actually, you'll see it in appearance, but this is a chart that's put out. But the real key here is if you look at these 2 samples, the sample on the right has 300 parts per million of water, but the oil still looks good. It's not going through many visible changes. Maybe if you would have taken a sample when it was perfectly dry and a sample now is a 300, you might be able to see it. But like I say, in most cases around a facility, if you put it in your sample jar, you're not really going to see it at those low levels. Now, the one on the left has 1,000 parts per million of water. So now it's very visible. A lot of times we'll see this in hydraulic units or gearbox where it gets foamy. It starts getting the little fine bubbles in it. Now, in a hydraulic unit, it could get foamy and look like this for another reason, and that means you're out of your anti-foam in the hydraulic oil. But this one here has 1,000 parts per million of water in it, and may also be from a hydraulic unit that is out of anti-foam. Now, your mineral oils go through a process called hydrolysis. So the hotter the oil, the more susceptible the mineral oil is of mixing with water. So if you've ever pulled a sample like this and you want to know if your oils went through hydrolysis, if you let this sample cool, sometimes you can put the sample in a refrigerator. If it clears up after about an hour, it hasn't went through that change yet. But if it stays like this, turns into a slushy, then that oil's went through a change. It's not really a good lubricant anymore. It's went through that process of hydrolysis, and it'll stay foamy and milky looking like this. So in this case, you need to change the oil. So your actions for reducing oil, we talked about these the last time. Where does the oil, or where's the moisture coming from? Well, it could be coming from your vendor. So I always recommend you go see your oil vendor. How are they storing your drums? How are they storing your buckets? How are they storing your greases? Are they controlled temperature-wise? Are they out of the weather? Are they away from moisture? So sometimes your vendor, and me and Justin's found this a number of times, where the vendor stores the drums outside under a lean-to, where they're maybe in the sunlight part of the day, or they get rainwater blowing in on top of them. You can actually get moisture from your vendors. How do you store the oil? You got to eliminate that moisture in your stored oils. Are they stored in a room? Is the room ambient controlled? Does the room go through temperature changes where moisture can go into the drum? Are your maintenance people putting the bungs back on, or are they putting desiccant breathers on the drum? So lots of things you can do here. Then is the moisture in your equipment, where's it coming from? So a lot of times in equipment, if it's outside on a piece of equipment, it rains on it, it heats up, it cools down. Lots of things can happen with the equipment. So you can eliminate the moisture from washdown practices. If you got a food plant or a pharmaceutical plant, a lot of times you'll have washdown practices there where water gets into the gearbox. So we got to monitor the moisture levels. We got to replace the lube whenever it's needed, because if the moisture gets too high, like I said, it changes the lubricant to something that's not a very good lube anymore. Getting better seals. One of the things the company I work for went to, instead of having the Chicago rawhide seals on some of our critical gearboxes and critical motors, we actually installed Labrador seals on those, which help keep moisture out. Using desiccant breathers on your equipment. These breathers on the equipment, because especially equipment that heats up and cools down or starts up and shuts down a lot, you definitely have to have a breather on some of that critical equipment. On your storage drums, I mentioned this before, people have storage drums in lube rooms. I've seen storage drums on the floor. These are good applications on the small port of that drum to have a desiccant breather on there. And we talked about all these devices we can use with dry air that will help remove the moisture. The moisture will actually go to the dry air to be taken off. So we talked about moisture, but now let's talk about these 4 materials. We talked on the last session about, this lube film thickness on our equipment being 5 microns. So what is a micron? Well, microns are very small. So bacteria is 3 micron. But look at what the lube film thickness is. It's around 5 microns. Talcum powder is around 10 microns. The fine floor dust that you may get off of a door seal or a picture frame, those particles get up around 40 microns in size. We can actually visually see those. And a lot of times that's the kind of dust that's in our lubricants. The human hair is around 80 microns in diameter. So again, we're talking about very, very small things, or very, very small particles that are causing our wear. If you order our little mini lube manual, you'll see this chart in there, and you can see the naked eye visibility limit's around 40 microns. So that's the largest particle the human eye can see. So we have to even watch particles of that size and try to figure out how do we keep those particles out. Now, as you look at this chart, some of the heavier stuff you may get in your oils, when you get up around 70, 80 microns, that stuff may be heavy enough that it'll go to the bottom of your hydraulic unit or gearbox and may not cause any wear. But if you look at the very top right-hand corner of this page, you got fatigue particles. These are particles that come off of your equipment. And big flat particles like this may float around the equipment. They may go into between your components. We even have to watch some of these particles that are coming off our equipment so they don't come back around and go right through the gears and the bearings. This is an interesting slide. This is a slide from Caterpillar's training, which this indicates human hair is what it's supposed to illustrate. Caterpillar in the industrial business has been very, very reliable around the world, for a long time. They're known as one of the most reliable pieces of equipment in the mobile equipment mining industry that there is. But one of the reasons that Caterpillar equipment is so reliable is because they do a great job of filtration. They filter all their lubes in their hydraulic systems. They filter the lubes in their engines, their transmissions, their rear ends, even their fuel. Caterpillar's real good about filtering with fuel filters because they never have any trouble with plugged ejectors. But what they're trying to demonstrate here's a human hair, and they're trying to say they don't want any particles around that 30 or 40 microns in size in their oils. They'll try to get some of those small ones. They don't really worry about the ones that are 1 micron. But you can see there that these particles, if we keep these particles out, Caterpillar's proven with their equipment since the mid-'80s that their equipment actually lasts longer. So again, this is another illustration of the same things we can do with our industrial equipment, same things we can do with our mobile equipment. One of the biggest mistakes I see in the industry is when you go to these mines or you go to some of the facilities that have the big CAT equipment or even anybody's mobile equipment, you'll always get people coming through there that say they have a filter that's just as good as Caterpillar's filter. They have a filter that's just as good as these low micron filters. Baldwin's an example. I was at a plant and the company had switched all their mobile equipment and their plant filters to a company called Baldwin. Well, Baldwin makes filters in England, but the Baldwin filters are just paper cellulose filters. They'll never filter particles down to these real low micron levels. So you have to be careful with these. But the Baldwin filters are, a fourth or a fifth of the price of the good low micron filters. So you get corporate procurement people and people that don't understand the beta ratings. They actually buy these cheap filters, and they actually start getting equipment failures when they're doing that. But again, these small particles. If you look at this lube film thickness on this loaded bearing right here, what they're saying, it's 1/20th the thickness of the human hair. What that bottom part of that slide showing is, if you look at a bearing or you look at a gear, to the naked eye, everything looks like it's really smooth. But in reality, those are rough surfaces under the microscope. That may be a half a micron or 1 micron in size. But we have to maintain that lube film thickness in there to keep those points and valleys from ever touching. But if we get particles in there that are larger than that film thickness, we're actually going to have a lot of wear. Talking about lubing, if now that you know how small these particles actually are, how many particles can I get around this little groove of this grease zerk? If you're talking about 40 micron particles, let's say we can get 100 of them around there. Well, every week or every month we do the lube task, those particles get pushed into the bearing. So we have to have procedures in our place with our maintenance people to keep particles off this ball, keep a little bit of clean grease over the top of this so particles can't get to the ball, or we can use those fancy colored caps to keep our grease zerks clean. But again, a good training session for maintenance people and making them aware that the particles are so small that we're going to pump those in to our components every week. Now, some things we can do to get away from that in lubing is that as you take these off and install automatic lubers. Automatic lubers, one of the things they do, like this one here, one of the things they do, they keep that failure mode of a dirty grease gun or somebody pumping particles in every week. Now we stick this automatic luber on there one time, so there's no particles can get in, there's no dirty grease gun, there's no dirty grease nipples, and it puts clean synthetic grease into this bearing. They're showing here all the time. Now, some studies we did at a couple of my customers and for the company I used to work for is once we installed these automatic lubers, and one of my customers, I won't mention the name because they don't like me talking about what they're doing, but they had bearings that failed every 8 months on their mean time between failure curves, and they were all lube tasked by operators and maintenance people. Bearings ran pretty hot in that operation. We put the automatic lubers on there, and now they're at 5 or 6 years with no failures. So not only, a lot of times they'll say it's 3 to 4 times the life, they're up to much, much higher numbers of that now because they're keeping that constant film of lube on their rotating components all the time. So great success story, and I've had other stories at other plants. I haven't got that kind of a life, but we took some grinder bearings on some big hammer mills that used to fail every 16 to 18 months, and the company's over 3, 4 years on those now. So again, some big success stories. Now, how do they work and why do they work so much better? If you look at this slide, the blue line is your maintenance person. He goes out there and puts some lube in a bearing every month or every week. And then over the course of time, it runs out of lube or may run out of lube, and then he comes back and replenishes that lube. So that blue line is that manual lubrication cycle. But I know like some of the plants I've been in the last 2 months, they're doing so much reactive maintenance, they're missing a lot of their preventive maintenance task. So what happens here when you have a lot of reactive maintenance, sometimes all the PMs don't get done. I was at one facility where I actually found the maintenance guys were pencil whipping a lot of the PMs because they were lube tasks that they had to do on the top of a bucket elevator. So they may have to climb 100 or 120 feet to the top of this bucket elevator to perform a lube task of greasing the head bearings. Well, those weren't getting done. They were being pencil whipped. So what the automatic lubers do would be the white line right here. You put them on, you get them calibrated for the right amount of grease, but what they do is they put a little bit of grease in at a lot shorter time frequencies. And you can set this time frequency up to whatever you want. But what happens here when you do this is that bearing has always got a constant film of grease. And the other thing that happens here, you use about 30 to 40% less grease. So the story on this bearing back behind here that we just looked at, these bearings went from a greasing cycle of every week, putting 4 shots in, which was using a lot of grease, and those bearings lasted 8 months, to what you see here with this automatic luber on here, and this bearing now getting a film of grease on it constantly, and this bearing went to a life of like over 3 years. So these work in areas where you can't afford to miss a greasing cycle. They're great for areas where maybe it's hard to get to in bad weather, areas where there's lots of moisture, maybe lots of rain or lots of water from the process. They keep grease in there to keep the moisture out. Maybe in areas where there's high particle counts, and we keep some clean lube in there to keep particles out of the bearings. They're great for like electric motors that are mounted maybe on if some of you are located on the coastal areas where you have salt water in the air. I've got a number of customers that have automatic lubers on their electric motors, having great success with that. So lots of applications, but definitely something you want to look at. But here's what happens in our equipment. So here we have a component. It could be a bearing, it could be a gear, but we have this 5-micron film thickness. And what happens, these particles get in between those surfaces, and our components actually grind those particles up into much smaller particles. So that's why a lot of times on a lab analysis report, you'll see the particles around 4 microns, that small number. That number goes up drastically on a piece of equipment. Well, it's because you're taking the 40-micron particles and you're actually grinding them up in all these small particles. And then in the process of grinding up those particles, you're actually wearing out your components. And at some point, some of the particles will be iron off your components. So I've got in one of my training classes, I have some slides in there where it shows the ISO codes on the oil getting dirtier and dirtier, and then all of a sudden it shows the iron number and the tin number going up on the lab report. But when you see that number increasing, what that means is you're actually wearing out the components. Those iron numbers are actually increasing in your lab analysis sample, and it's due to wearing out the component. So here's another just illustration of this. You know, as those particles get caught between that film thickness, and you could, like it says here, you could jam the particle and slide it. You can actually crush the particle and cause damage to your component. But the particles, a lot of times, don't leave there. They continue to go around in raceways, especially if you have journal bearings. They stay inside of a journal bearing. It's a lot of times why you'll see lines carved on the journal bearing housing. It's because that journal bearings had particles in there. And you can see that there's a lot of weight that can grind up just about any particle there is, which is going to cause damage over time. So here we have a little schematic of this. We have our bearing or a gear. We get a foreign material particle. At some point, that foreign material particle starts to wear off pieces of metal in our system, and that metal starts going around the system. So particles can be hard enough to do this. So here's an illustration. We have two body wears where the components actually rub together. Three body wear is where we have particles in it that are causing the component to wear out. But look at this slide where it shows these slide marks. This is looking at a bearing surface under a microscope. All those lines you see on there are caused by particles that were in the lube. And so if you take some of your bearings and cut them apart, and you look at them through a little microscope, this is what you'll see. Now, one of the things that I've purchased since I've been on my own, we had one at our facility, was a little digital microscope. You can buy a little digital microscope that goes from 100 to 300 power for $300 approximately. So with that little microscope, you can make a little stand on each side, and you can actually cut a bearing race apart after it's failed or after you take it off, maybe from a predictive technology, and we can actually see a bearing surface that looks like this. It's got scratches. In this case here, you got a particle embedded in the metal. So again, this is what's happening to your components and the reason your components are failing. But these are things you can't see with the naked eye. This was looked at a bearing surface at under 100 power microscope. So you can see what the difference is. But a good illustration. This comes from Nori. I hope they don't mind me borrowing the slide, but this is rolling motion, having a particle there, and it's a good illustration of what's happening. You're actually peeling off the surface of the metal and creating more particles. But if you look at these surfaces, we start off with the upper left-hand corner, and we got a nice uniform fluid film there. We start developing cracks in our system. These cracks become pits at some point, and the pits may only be 1 micron deep in your bearing metal. But as you get these pits, it weakens the surface. And then another thing that happens, what if we get moisture down at the bottom of that pit? What if our oil's oxide, we get a high acid number? So now we have some corrosion going on. We have some temperature changes going on. We have all the pressure of the bearings running across this surface. And eventually, we destroy that bearing surface in the in the micron stage, but eventually they become big enough that the human eye can see. And as some of you taken bearings apart in the past, and seeing the bearings, you find out that these bearings have those little pits and cavities in there, and we've caused those with the things we do with our process of lubrication. Here's another good picture here, the start of a bearing failure. You have these little 0.5 and 1 micron imperfections. You know, we get an initial crack started that may only be 1 micron deep, but again, so this crack network builds up. We start losing these pieces, and then this is where we see these little pits and cavities that are actually forming in the surface. Now, it's very hard after you get these pits and cavities and this starts wearing like this is to maintain our lube film. So by having these pits and cavities, it increases the failure of that bearing or gear surface, you know, to another level. And this is what you would see. I don't know if any of you have looked at bearings, but if you look at this ball bearing in the bottom with the little pits, this is all caused initially from foreign material and different things that are happening in your equipment. If you see the gear line up here in the upper right-hand corner, if you ever look at a gear line and you see pits and cavities on that gear line, more often than not, those started from started from foreign material particles that were in your lube, and we didn't maintain the lube film. But again, as you start getting the pits and cavities, it's very, very hard to maintain our lube film anymore without damaging the surface even more. I was attended a SKF bearing class, or it was a Timken bearing class many years ago, and what they were telling me is the loaded portion underneath the loaded part of a bearing or a gear, you can develop 20,000 psi of hydraulic pressure, and that's enough hydraulic pressure to do a lot of damage to your surfaces, just hydraulic pressure alone. Look at some of these slides. These are slides under a microscope. And that's another thing, too. If you're thinking about buying that microscope, you can put drops of oil underneath your microscope at 100 power, and you can look at those drops, and you may see particles like this. So these are little small 20-micron particles in the upper left-hand corner. These are 20-micron particles of brass that were in a sample. This is from analytical photography. These are 10-micron particles of metalware that was in a gear oil. The lower left-hand corner, this is from a power plant, so you can see silica, fly ash, and different things on the slide here at 20 microns. Again, too small for the human eye to see. And here's a 20-micron particle of buried metal or gear metal that was showed up in a slide. But look at all the little broken up stuff around it, all the stuff that's really small, that may be 2 or 3 microns in size or 4 microns in size. Those particles were probably ground into that size from some of these big particles. But a 20-micron particle like this of bearing metal or gear metal, if that would happen to go through your bearings or go through your gear, it's going to cause some damage to some of these pits in your equipment. Here's some bigger particles. Now, when particles get above 40 microns, when they get to that 65 micron size, if you have a sample jar, you can actually start seeing that little dust ring. You can see some of these particles in the jar. So there's been times at facilities where people bring in a sample like that, and it's got that dust ring in the bottom. Once you see that, you make a decision. You may want to know something else about your oil sample, but you should also maybe make the decision, is it really worth sending that sample in if I can actually see the particles in there? It may not be. Now, if you want to know some other things about your oils and this sample, that may be all right, but these particles, like this, that lower left-hand part picture right there, you know, that's going to cause a gearbox to fail in probably a month if you have that levels of fly ash, silica, and dirt in a gearbox oil. And like I say, if you can see it in there, you've got some big wear particles. And one of the things I wanted to make sure we cover in this session, when we get particles out, we have to understand filters, because all oil filters are not the same. But you'll have people come in all the time that tell you their oil filter is really good, it'll take out a certain number of particles. But a lot of filter companies that are very popular in the industry, and Parker's a good example of that. If you have a Parker filter card, or you call Parker and buy filters, if you ask them what the beta rating is, they don't beta rate their filters. They're rated for some micron sizes, but they don't have any efficiency rating on their filters. So they're not very good filters for what we're trying to do in lubrication excellence. They're all right in a mine to take big particles out, but they're not okay in some critical equipment to get small particles out. So all oil filters are rated for a particle size and they're rated for efficiency. So the particle size is always going to be in a term called microns, like we've been talking about. The efficiency rating on our filters is always going to be in a term called beta. Oops. So particles in these size ranges that we're going to talk about, we can't, like we said, we can't even see them with the naked eye, and they're going to cause severe wear to your components. So if you take a hydraulic system, you're going to have, in a standard hydraulic system, you're going to have millions of particles in there, and they have to, at some point, be filtered out. Now, one of the things I've noticed, most hydraulic systems that manufacturers sell you, they have filters on there, but the filters are not beta rated. Some of your old hydraulic units around your plant with the little small filters on there, those filters aren't much better than a car filter. They're just a paper filter. They'll take some big stuff out, but they don't get that small stuff out that's going to cause damage. So these filter ratings, so a nominal filter, this would be like the filter you have on some of the old hydraulic systems. That are another example, that'd be like the filter you have on your car or your pickup truck. They're just paper filters. They will take out some particles. The absolute filters, the beta-rated filters that are in the industry, they're rated for the absolute diameter of the largest particle that will pass through the filter. So they actually have an efficiency rating on them. So the term beta, when you call filter companies and you ask for a filter, you'll ask for a micron size range, and you'll ask for a beta rating. So as an example, the filters we put on our filter carts here in the company or in our lube rooms we build, they all come standard with 10 micron beta 1000 filters. So that beta number gives us the efficiency of the filter. So it says here in a lab condition they count the particles upstream, of the filter, then they count the particles downstream, and they give that filter an efficiency rating. So let's say in the lab condition there was 50,000 particles upstream, and there's only 250 particles downstream. Well, if we divide that out, that gives that filter a beta rating of 200. So in this case, it'd be a 5 micron beta 200 filter. But a beta 200 filter is 99.5% efficient. So here's what it would look like in a lab condition. You have particles upstream that are measured, particles downstream. We develop this beta rating. So some common beta ratings, like a standard car filter that was in your car. If you buy the cheap one that Fram puts out, it may have a beta rating of 2, have an efficiency rating of 50. Some of the best oil filters on the market, your Fram Tough Guard and your Mobile One, they have efficiency ratings on the box of 96 and 97, which puts them around this 50 beta rating. But you can see, like I said, the filters we put on our equipment here, the company, they're beta rated 1,000, so they're 99.9% efficient. But look at this efficiency chart here. You can see at the 1,000 beta line, they're 99.9. You can take out 100,000 particles all the way down to 100 particles. Now you can keep going up, like this 1,000 rated filter right here might cost you $75. Once you go to 2,000 beta rating, you're probably going to talk about $140, and they just double in price. But you can see the efficiency numbers here don't really go up that much. So if you go to a 50,000, you're only at 99.998. So what we try to do in our company is we'll put 2 of the beta 1,000s in series. So you go to the first one, you reduce your 100,000 down to 100. You go to your second one, reduce your 100 down to 1. And so we could get some pretty good efficiency ratings using 2 beta 1,000 filters in series. Now, when you're talking about filter materials, a lot of times vendors come in and they say, oh, I've got these filters and they might be 10 micron beta 1000. The very first question you'll want to ask them is, what is the filter media made out of? You know, if they say paper or they say cellulose, there is no way to get beta 1000 with paper or cellulose. Not even really many of the cloth ones can get those kind of beta rated numbers. But if you look at filtration materials, like if you take a Donaldson filter, for example, it'll be made out of a material called Syntac. Well, Syntac is these fine microscopic hairs that actually catch all the particles. So those are the kind of filters you're going to get these high efficiency beta ratings out of. But like I said, you can't get it out of paper. You can't get it out of cellulose. You know, sometimes you'll have vendors come in and they have stainless steel screens and they'll tell you they're high beta rated numbers. Well, you can't get the high beta rated numbers with stainless steel screens, especially the ones that are cleanable and reusable. So don't be trapped into buying things like that won't get the results you want. It has to be this synthetic media, lots of hairs, lots of fibers that capture these particles. Now remember, before we talk about this slide, if you're going to change filters, like let's say you've got an older hydraulic system and has one of these little short filters on there. If you're going to go from that 20 or 40 micron filter to a beta rated filter, then it has to be much bigger. So a lot of those will be 4 or 5 inches tall. You may put a 12-inch filter on there when you go to the low micron numbers to be able to get the surface area you need to capture those particles. But another example I want to talk about is your car filters. You can see the efficiency rating on some of the car filters that are out there for your automobiles or pickup trucks. A Mobile One filter is 96.1% efficient. You got a Fram Extra Guard, which they sell is 93. But this AC DuraGuard and some of the cheaper Fram filters, like the one you buy in Walmart for $2.86, or the ones they use at the Jiffy Lubes when you go through, you can see their filter efficiency is about 33%. Here's a Fram Tough Guard that's 96. So a lot of times when I get my oil changed, and Justin does the same thing, he's online, we actually go buy our own filters. And when I go in to get the oil change, I hand the guy the filter and say, change my oil, and I want this filter. And have them put that filter on there for you. Sometimes you can ask for the Mobile One filters and they'll have them on there, but many times not. Now, when your oil filters, when you start filtering your oil down to these real low levels, when you send your oil analysis samples in, the results you get back on your oil analysis samples are going to be very low. You're going to have the oil cleaned up. But what the purpose of this slide is don't throw the filter away when you get done, because that's where all your particles are. So there's a number of labs like Test Oil or Insight that you can send the filter to it. They'll back flush the filter, tell you what's on the filter, and send you pictures back of what's on the filter. the guys at my plant, we made a little tool with a cutting wheel off of a pipe threading machine, and we actually cut the filter, took it off, and then we ran a magnet up and down the filter to see how many iron particles on there and what they look like. Sometimes we would scrape the stuff off and look at it under our microscope. But just this slide's trying to point out is all those particles that you filter out of your equipment, they're stuck on that filter somewhere. So if you want to see what they are or keep track of how much metal's in there, how much wear you have, it's in the filter. This is just a picture I saved for a long time. It was something one of my maintenance guys found on a Y strainer before a filter. You know, a pretty good chunk of metal. And we looked through this gearbox, never did find out where it came from, but you know, it came from something, and it could have caused a lot of damage. Your online filtration systems, a lot of times we can't change the filter in our hydraulic unit, so then we need to buy a filter cart that we can move around our plant, and we did this a lot at the facilities I come from. I have a lot of customers that have filter carts. We take it up to a hydraulic unit, we hook on the bottom of the hydraulic unit, we circulate through the filter cart and put it right back in the top. And by doing this, we can filter our oils down to real low levels. We can buy whatever micron filter we want. Lots of companies make these. You know, if you buy a good two-filter system, you're talking $3,200, $3,800. We kind of pride ourselves. This is our filter system here. It's got sample ports and everything you need, and this filter cart here is only just a little over $2,000 with all the options and all the accessories. Now, what I did at my plant, as a reminder, if you want to save some more money, I just bought my guys an electric pump. I bought them a couple of filter cartridges. I bought them some hoses, and I bought them a two-wheel cart. And my maintenance guys built their own filter carts. That way we built them the way we wanted them, with the kind of hoses we wanted on them. But again, there's lots of options in buying filter carts, but they're very, very nice to have around a facility because you can filter your gearbox oils. You can actually use these to filter the oils in your drums. Your new drums, because most of the time the oil in your new drums is not clean. So in this case here, we have an electric pump with two 10-micron Beta 1000 filters. You can also make these with air diaphragm pumps, air piston pumps, so lots of options there for use in your plant. We can put explosion-proof motors on them if you like. This is a little lube trailer we built for a number of our customers. We've sold about 50 of these now, but this is a little four-wheel trailer you can pull around your plant, which has a little tank on it with 22 gallons of oil. You can filter the oil in the tank. You can filter oil into the tank. You can go up to a component. You can kidney loop it with this air pump and clean up a hydraulic system. You can use the hose reel to top off hydraulic systems and gearboxes. So lots of little uses for a little four-wheel cart that can be taken around the plant. Here's a system on a wall where you can put your drums up there, and you can either recycle the drum or transfer it to another piece of equipment. But this has a particle filter and a moisture filter on it. So this is something else you can build, or we can build for you. But again, nice way to clean up drums and systems. This is a cart at a grain elevator. We built this trailer. It's got a dirty oil tank, a clean oil tank. It's got a little generator on the back with an electric pump. But you can pump up to the top of bucket elevators, the top of high conveyors. We can change oil in those conveyors pretty easily. With this little trailer, you can pull around. So lots of things you can do, you know, with these little trailer type things if you got a large facility where you need to drive around. Lots of options there. I've even built these with generators and air compressors on them. So number of things you can do here for equipment around your plant as you move around. But again, you know, make sure you can filter your equipment all the way down to 3 microns. You have to be careful going below 3 microns because you can filter out some of your additives in your oil. There's also cartridges we can put on the filter carts that actually filter out moisture. They actually have desiccant inside the filter. Your filter frequency, how often should you use a filter cart? Well, you can use a filter cart, you know, every month, every quarter, but sometimes you have to pull some oil analysis samples to see how dirty the oil is, and then determine what ISO code you want to get it down to in your filtration system. But if you just take a hydraulic system, if we look at a 22, 19, 17 hydraulic oil, we filter it down to this area where you'd be with a 10 micron Beta 1000, and look, it's 5 times the life on that hydraulic system. If you've got dirtier oils, you can see it's pretty easy to get up to 10 times the life on your hydraulic systems just by cleaning the oil. So some best practices in filtration: size and order all your filters using beta ratings. Make sure they're beta rated. Properly size the filter for the correct flow. It says don't filter below 3 microns so you don't filter your additives out, and be careful with your bypass type filters. And what I mean by that is all these filters have a bypass in the top So when the filter gets dirty, it's just going to push the bypass open and dirty oil is going to circulate around your system. In the case of your car, if the filter plugs on your car, your pickup truck, that dirty oil just filters around your system. All your car filters have a little spring and diaphragm in the bottom. If the filter gets dirty and plugged, you just circulate dirty oil around your engine. So another good reason when you change your oil to get a good filter on there. Some of your better filters have more surface area due to the pleating. Microscope. Like I said, if you want information on the microscope, you can look at particles under a microscope. The filtered paper I told you about, putting a couple drops on there and monitoring the filter paper. You can also see rings form on there if you had a lot of particles in there. Place the oil in a sample bottle, keep the oils in the sample bottle on the shelf over time, and we can see changes in the oil just looking at the sample bottle. Lots of things we can do without using a lab, but the labs are the best way to go. Your lube equipment storage, where you're getting particles from, how are you storing your equipment? Keep your grease guns in a plastic bag. Keep all your containers in a cabinet if you're using oil-safe containers or other containers for moving your oils around. Keep them inside a cabinet. All your filters should be sealed. All your funnels should be in plastic bags. You can buy Ziploc bags from McMaster-Carr in any size you want. But keep those filters in a bag and keep your lube equipment in a bag. You're trying to eliminate every particle. Checking your oil. Many failure can be seen with just a good monitoring program. So like I say, train your operators, start pulling samples, monitor the oil so you know when to change it. Lots of good practices around that. So that's the wrap up for today's session. We have a few minutes if there's any questions you want to type in. You have the email address here. If you've got questions you want to email, I'll get those questions answered right away. But I'm hoping you learned some things. Like I said, lubrication is at the top of our performance failure curve. If we get the lubrication process under control and get our lubes clean and dry, you'll start seeing those longer life cycles of your equipment. Now, next month, we're going to talk about how to predict failure. So there's some definite predictive technologies that you need to know about and a lot of cheaper tools on the market instead of paying the Vibe Guy to come through every 3 months for $5,000. There's some very good vibration tools, very good ultrasonic listening tools we'll talk about next month that'll help us with a lot of things. So again, thanks for attending the session today. If you need to download the recording of this to play to your maintenance people, feel free to do that. Yeah, I don't know if somebody's trying to ask a question. I can barely hear you on there. All right.